I'm going to give you an example just to show you why the moment due to couples are independent from any point you chose. Okay, so go back to look at the example. We have a three-dimensional rigid body. Okay, the piping system, for example. Okay, the blue color. So we have this piping system, and there are four forces acting on different locations. We need to determine the components of the single couple equivalent to the couples shown on the left. Okay, so here is a rigid body. We have four forces, but if you look at those four forces more carefully, there are something very special. First of all, let's look at this force acting on point E, which is to the left, 20 pounds. And then another force acting on point D to the right. These two forces are having the same magnitude, parallel in opposite direction. So these two forces form a couple, right? That are correspondingly form a moment. Okay. Also, if you look at these two forces, one force acting on point C with a 30 pounds, another force acting on point D with a 30 pounds, but to this way, this is to the other direction. These two forces also form a couple, or say another moment. So then we just need to add all the moment together, which can determine the single moment or single couple due to this scenario having four forces. Okay, there's many ways you can solve this problem. So for example, if you go back to look at the way the textbook trying to solve this problem, they simply say, okay, in order to calculate this single moment, what I'm going to do is to pick a point, pick point D, or pick point A, or pick point B, point D, I'm sorry, not point B, point D. You can pick point B as well if you want, okay? And then you are going to calculate moment of a force about this point you pick, okay? So you pick point D, and then you add them together. You get a solution. You may say whether this solution is dependent on the point you pick, and the answer is no. Okay, and then I'm going to show you another way to solve the same problem and should have the same answer. And just want to demonstrate, in fact, you can pick any point you like. Okay, for example, if you come back home, you want to, I want to pick point C. You do the calculation, you finally end up with the same result. The reason the text will pick point D because that's the simplest way. Okay, they can pick different points, finally end up with a result. It's just kind of detoured a little bit, but the final result should be the same. Okay, back to this problem. Let's first take a look about how the text was trying to solve this problem. Number one, you randomly pick a point. Let's say pick point D. If you pick point D, then you just calculate the moment of this force about this point D, the moment of this force about the point D, the moment of this force about point D, and the moment of this force about point D. You add them together because that's all vectors, right? You can add them together and you get the result. Okay, so first of all, let's take a look about the moment of this force, 30 pounds at point C at point D. Okay, let's do what is the moment of this force about point D. Well, that's the first type of moment, the moment of force about a given point. So what you need to do is using R cross F. Okay, using R cross F. What is R? R is the point you want to calculate the moment to the point that force applied, this force applied, right? So that's going to be D to C. D to C. In other words, use a C subtract D. C subtract D. All you need to do is first set up the coordinate system. Let's say this is the X direction, this is the Y direction, and this is the Z direction. So point C, you have three components, 0, 9, 19, right? So 0, 9, 19. And then this point D, 0, negative 9, and then 19, okay? But actually, if you look at this from D to C, that's the direction, the vector, distance vector direction. That's in fact is parallel to Y. So then the magnitude from D to C is 18, 9 times 9 plus 9, 19, and then J. So basically, D to C, you can use C subtract D, you get the result, or simply this one parallel to this, you basically get 18J. So this is R. So this is R, which is distance from D to C, and then cross this force. Cross product between this R vector and the force vector. What is a force vector? a force 30 pounds at point C. So the magnitude 30 pounds, put the 30 pounds here. And then what's the direction of this one? This is parallel to this z direction, but in the opposite way. So then it's going to be negative k. So finally, this force, using the vector, is going to be negative 30k, because this is in the opposite direction of k. Okay? So R cross F is the moment of this force about point D. That's the first part. I'll leave it there. Second, what is the moment of this force about point D? Same thing. What you need to do is to find the R vector is from D to E this time, right? Because you want to calculate the force moment of this force at point D. That's going to be D to E. Okay, so you connect these 2 points. So from D to E. So then R is equal to E subtract D. So we already find out the 3 components of point D. That means 0, negative 9, positive 19. And what are the 3 components of point E? The 3 components of point E is 0, 0, and then 7. Right? So these are 3 components. And this one subtract this, and this is what you'll get. So this is the R vector, distance vector, from D to E. Okay? So this is the R vector. Cross the force vector. So here is a force with a magnitude 20 pounds. So you put 20 pounds here and then look at the direction. So this force direction is parallel to x direction, but is an opposite direction. So that's why you have a negative I. So negative I is the direction of this force, and the magnitude is 20. So then this is R cross this. So you can do the simple cross product, and also do the simple product between the about the first term, and you add all together. This is your solution. So this is the equivalent single moment due to these 4 forces. Okay? So from this, you may not, I'm sorry, I forgot to mention these 2 forces, right? Why I do not need to consider 2 additional terms? Well, what is the moment of this force about the point D? That's going to be R cross F. R is from the point you want to calculate the moment to the point the force applied. So that's the D to D. So D to D is 0, right? Because you are not really moving anything. So that's R is 0. R with a 0 cross anything equals 0. So that's why I don't have the third term, calculating the moment of this force about this point, right? Same thing for this force. What is the moment of this force about point D? Then that's R cross F. R is from D to D. That's 0. That's 0 cross anything equals 0. So that's why I don't have the third term, I don't have the fourth term, because both terms are 0. And that's another reason why I want to choose point D. If I choose point D, in fact, I only need to calculate 2 moments. The moment of this force about this point, and the moment of this force about this point. I don't need to worry about these other 2 forces. If you want to choose point A, which is here, for example, right? If you want to choose point A, and then you want to calculate out the moment of forces at point A, then you need to take 4 terms. And you add them together, you finally end up with the same result. Okay? So that's, first of all, just want to show you, you have forces, 2 couples, you pick any point you like, you get the same result. Number 1. Number 2, if you see these 4 forces forming 2 couples, you even do not need to do this by picking a point and the calculate moment. What you need to do is basically using here. Because when I have a couple or 2 forces forming a couple, then I use R cross F to get the corresponding moment. And then if I have another 2 forces, and I do the same thing and add them together. This time you don't need to pick any point. And the result is still the same. So I'm going to switch to the overhead projector just to show you. For this problem, I can basically calculate the moment due to this and this forming a couple, and also the moment due to this couple. And add them together, it should finally end up with the same result. So let me show you. Okay, so that's the same. I just basically copy the picture from the book. So how are we going to calculate the moment of these two couples? So number one, I want to calculate the moment due to, let's say, due to these two forces forming a couple, right? So let's say the moment due to the first one, which is R cross F. This F is having 30 pounds as a magnitude, for example. You put the 30 down. Okay? What is R? R is the distance vector. Is a distance vector from, it depends on, let's say how to determine this F first. Okay? So this is a force vector, but I have two forces, right? This force and this force, they are the same, but in opposite direction. So you need to decide which force you want to count as this. Let's say we count this one. So this is the force. So then this R should be any point the other force acting on to any point the first force in the force line. So in other words, you can have this is R, anywhere is R. But from this to this. In other words, for this problem, this R is from C to D. If I choose this force here. If you want to choose this force, is this one, then it's going to be D to C. Okay, so any point for the second force acting on to that point, the first force acting on. Okay, so R is from C to D, and then cross this force. Okay, so now let's do one by one. What is R from C to D? This is R. So obviously the magnitude is still 18. It's in y direction, but it's opposite way. So that's going to be negative j multiply 18. So this is the distance. And then cross the force. So make sure this is the force. So the magnitude is 30 pounds. And what's the direction? This is the direction, which is in z direction. That's k. Okay, so that's the moment due to these two special forces forming that couple. So then it's a negative 18j cross 30k. So you can easily do the math. J cross k equal to I. So it's going to be negative 18 times 30 I. Okay, so this is the moment due to this couple. Any questions? Okay, so second, we want to, yes?
Why was it positive 18J?
Okay, so again, this R can be anything, but before you determine this R, you need to pick what is the F you are talking about. Okay, so you want to pick this F, which is this. Then this is going to be negative 18. However, you can say, I don't want to pick this one as this force. I want to pick this one. No problem. If you want to pick this one, let me show you, because the result is the same thing, finally. So then you are going to have this force, right? So this force is 30 pounds in this negative z direction. So that's going to be negative k. If you pick this one, then it's going to be this R, back to this R, is going to be here to C. So then, oh, I'm sorry, put this one. Oh, wait. Did I make a mistake? So that's it from here to here. Oh, yeah, that's right. So D to C. So D to C, which is 18 positive J. So D to C, that is 18, which is positive, and then cross 30. So you still finally end up with a negative 18, 30, and J cross K equal to I. You still have the same result. The definition is R cross F. So you need to first, that's a third type of moment. Number one, you need to determine which F you're talking, because now we have two Fs, because there's two forces, right? So you identify one F is something you want to use. And then the corresponding R, which is to be crossed with F, that's R is from the point the second force applied on to a point the first force applied on. Okay, so that's why for the first one it's going to be negative. The second one is positive. But the final results will be the same. Any other questions? Yeah.
Same one. So, can we use the coordinate to describe the point C and D and find out this?
Sure, no problem, because this is relatively simple, so that's why I've just show you that. Okay, fine. Okay, so back to this one. This is the x direction, this is the y direction, this is z direction. Okay, so what are the three components of point D? The three components of point D, you told me 0. What's the second one?
-9.
What's the third one?
19.
19, right?
Yeah.
Okay, this one. And then what's the three component of point C?
0, positive 9. And 19.
Okay, good. So now, let's do this. From C to D, okay? From C to D. From C to D, that means?
D minus C.
Good. So D minus C. What I'm going to do is 0, -9, 19, subtract C, 0, 9, 19. Can you see that? Okay. So then let's do the math. Don't see anymore. 0 minus 0, 0. -9 minus 9 is -19, 18. 19 subtract 19, 0. So this is the one. Sometimes in vectors, you can write like this way, or you can write 0 times I plus -18 times j plus 0 times k. That's exactly -18 times j. Compare this one with here. They are the same. Okay, so it's really up to you. The reason I just simply write this one because this is really simple. It's parallel to one of the three axes. But in general, you need to do this if it's not parallel to any of the three axes, right? So it's better pick up those three components and then do the math in a simple way. But this is guaranteed to get correct answer. Any other questions? Okay, so let's move on. So that's the first one. We calculate the moment due to this force, right? Now move to this one. Step number 2. What is a moment due to these two forces, right? Okay, so that is called moment 2, which is again R cross F. That's a universal definition. First of all, let's determine this F. So we have two Fs, 20 pounds, 20 pounds. It's really up to you. So you want to choose this force at point D or point E? Anybody give me a suggestion? Point D. Okay. So then this force is a force at point D. So see, the magnitude is 20 pounds, right? Times the direction. The direction is parallel to x and to the positive, to the right. So then it's a positive I. So this is a force we picked. Okay? Then what is the corresponding R? That's R is going to be the second force applied. Okay? To the point, the first point, the force applied you just picked. So that's going to be E to D. Okay? It's going to be E to D. If you want to choose from D to E, then you need to pick this force as and put in here. So I choose this force, that's going to be E to D. So that means R from E to D. Okay? Any questions? Okay, so E to D, that's this one. Of course, you can easily figure out, but just in case, let me assume you don't know how to get this distance vector. Let's do the component method. Okay? So what are the 3 points of the point E? Point E here, what are the 3 components? 0, 0, 7. Okay? What is a point D? 0, -9, and then 19, right? Okay? Okay, so now I do the math. E to D. E to D means what? D subtract E. Okay, so let's do D subtract E. So D subtract 0, subtract 0, 0. -9 minus 0, -9. 19 minus 7, 12. Which is 0i, 9j minus plus 12k. Okay, so this is the R vector I'm going to put in here. So back to this one. Let me move up. So R is -9j plus 12k and then cross 20i. Okay? And let's do the math. J cross I. What is J cross I? J cross I equal to -k. And -9 times 20 and then negative again, you get a positive 9 times 20k. So that's the first term due to the cross product between this and this. Second one, k cross I. What is a k cross I? That's a positive j. So then it's 12 times 20j. So this is the second. There's another moment due to these two forces, right? So from step number 1, we got the first moment due to these two forces. Where our final solution? Here, right? Is it here? Yes. Okay, so let me just use a new page just to write it down. Okay, so the final moment is moment due to the first one and the moment due to another couple. Okay, so the first one is negative 18 times 30i. And then the second moment is here. Okay, so I, J, K. You have 3. I hope you can memorize this one. I'm going to switch back to my PowerPoint. I hope that's the same. Otherwise, we made some mistake. Okay, I'm holding this page and then I'll check for you. Okay, so go back to this one. The I term is, I'm holding my I term is negative 18 times 30. Negative 18 times 30 is negative 540. Okay, and then J term, my J term is 12 times 20. 12 times 20 is 240. And then my K term is 9 times 20. 9 times 20 is 180. Okay, so IJK, that's the same with what I'm just showing you here. So the bottom line is, if you see those couples or forces forming couples, what is the corresponding single moment, you do whatever you like. Okay, you random pick a point and then you calculate all the moment due to all the moment of forces due to at this point. You add them together, you get the answer, something like this. Or you can just calculate the moment due to a couple separately and add them together. You get the same result. Any questions?
What is this final moment about?
Okay, so determine the components of the single couple which is equivalent to the couple shown here, right? Okay, so this is the result. Basically, if you want to answer directly for this question, what are the moments, right? Is the x component, I'm sorry. The x component of this moment equal to negative 540 pound-inch. The y component of this moment equal to 240 pound-inch. And the j components of this single couple moment is 180 pound-inch.
I mean, for the rigid body, what point is this moment about?
Ah, okay, that's a good question. Right now, we have this rigid body. You have 4 forces acting on different locations, right? So these 4 forces together forming a moment at any point. So, for example, if you say at this point B, if we have a support, which we're going to talk about chapter 4, if there are supports, then equivalently at this point, there is a kind of moment with the 3 components acting on this point. So in other words, you have a very complicated, complex structure like this. Okay? So then at this point B, you are having the x components of this moment. X component is the I direction. So this is the one, this is the I direction. Negative, that means you're going to have this kind of torque at this point. But this is not enough. You also have another kind of moment of torque, which is in y direction. That's J is here. So then this one, you're going to have positive. So you're going to have a rotation like this as well at that point, at this point, point B. And then number 3, you also have a a z direction component. That's in this one, which is a positive. You also have this kind of torque in the k direction, in z direction. Okay, but of course, I just random pick up point B. You say, okay, I don't like point B. I want to pick point A. Is that same? And the answer is the same. The moment, after you calculate the moment is independent from any point you choose. So that's why you can move the moment around.